Today we'll take a second look at properties of exponents. Warm up. Are the following true or false? If false, can you explain why and give the correct answer? So the first one, we have g to the 14th over g to the 5th. Does that equal g to the 9th? And that is true because you would have 14 g's on top and 5 on the bottom. So when you cancel, there's 9 left on the top. The second one, we have a squared times a to the 5th. Does that equal a to the 10th? And that's false. If you have 2 a's and if you have 5 a's, we can see that that should be a to the 7th power. And the last one, 19 to the 0 power, does that equal 0? And that's false. 19 to the 0 power equals 1. How do we get that? Well, we could do like 19 to the 3rd power over 19 to the 3rd power equals 19 to the 3 minus 3, which is 19 to the 0. And any number divided by itself is 1. So anything to the 0 power is 1, not 0. So these rules that we looked at yesterday, we looked at 4 of them. They have names. So the first one is called the product rule. Product means when you multiply two things with the same base, you're going to add the exponent. So here, 9 to the 12th times 9 to the 3rd equals 9 to the 12 plus 3, which is 9 to the 15th. And so the general rule for a to the m times a to the n is a to the m plus n. Okay, the quotient rule. Quotient means divide. I should write these down. So product means multiply. Quotient means divide. And if you have x to the 5th over x squared, you can think about canceling the x's to create 1's. So 5x's on top, 2 on bottom. If you cancel the 1's, we have x to the 3rd power. To get that, it's the same as subtracting the exponents. So if you have the same base and they're being divided, you can subtract the top, the numerator exponent minus the denominator. The negative exponent rule, another way to write 1 over p to the negative 2 is p squared. And likewise, if we have, I don't know, x to the negative 5, you can write that as 1 over x to the 5th. And so the rule is, if it's a negative exponent, you flip it. If it's the bottom, flip it to the top. And if it's on the top, you flip it to the bottom. And it creates a positive exponent. And the 0 exponent rule, anything to the 0 exponent is 1. And we talked about why that is yesterday and also in the warm-up. So we have a few more properties to add to our exponent rules today. The first one is called power to a power rule. So like yesterday, we're going to expand the exponents and look for a pattern or shortcut to find the right answer. So here this is x to the 3rd power, but it's twice. And so x to the 3rd power, if it's twice, we know we can add those exponents. So we get x to the 6th power. Let's do the next one. X to the 10th power, but we write it 3 times. 10 plus 10 plus 10 is 30. The next one is b to the 11th power 4 times. And so that would be b to the 44th power. And so the question here is, how do you take the 2 and the 3 and get the 6? How do you take the 10 and the 3 and get a 30? How do you take the 11 and the 4 and get a 44? Well, you multiply them. So here, z to the 7th power to the 5th power would be z to the 35th power. If you were to write x or z to the 7 out 5 times and add those together, it'd be the same as multiplying the 7 times the 5. And so this is the power to a power rule. If it's a to the m power to the n power, you multiply a to the m times n. Or we can write it a to the mn, because when we have two things next to each other, it means multiply. Okay, what if there's more than one base? Expand, simplify, and look for a rule. So what if we have x to the 3rd y, but twice? X to the 3rd y, x to the 3rd y. Let's look at the x's. There's 6 of them. Let's look at the y's. There's 2 of them. Let's do this one. 2x to the 5th, y to the 4th 3 times. Oops. These are all being multiplied. All right, so here we're going to multiply. 2 times 2 times 2 is 8. If you have x to the 5th, x to the 5th, x to the 5th, that's x to the 5, 10, 15th power. And if you have y to the 4th, y to the 4th, y to the 4th, that's y to the 12th. And so the rule here is, if you have this exponent, you multiply, but you're going to have to distribute to both of the exponents, or to all of the exponents. So if it's 2, it's 2 to the 1st power. And so we have 1 times 3 is to the 3rd power. 2 to the 3rd power is 8. We have 5 times 3, which is the 15, and we have 3 times 4, which is the 12. So if it's a power to a power with more than one base, you're going to distribute and multiply to each of the exponents. So for example, we have 4, which is 4 to the first power, x to the 12th, y to the first power. We're going to distribute the exponent and multiply. So we have 4 to the 5th power, x to the 60th power, y to the 5th power. You can simplify further and do 4 to the 5th power, which we'll do real quick here. 4 to the 5th is 1,024. So our final answer is 1,024 x to the 60th, y to the 5th. So again, if it's a power to a power with more than one base, you're going to distribute and multiply each of the exponents. So this is a to the n power, b to the m times n power. Okay, so we're just going to do a bunch of examples of all the different properties we looked at yesterday, and then your assignment will be more practice with these. Okay, so if you have parentheses, do the inside first. We can divide 14 divided by 2. So we have 7, and then we have 5 x's on top and 1 on bottom. So when you cancel, you have 4 left on top. All right, so do the inside first if possible, and then if it's a power to a power, we'll distribute to each of these exponents. So this is 7 squared, and then x to the 4 times 2, which is 8. 7 squared, we can go a step further. We know that's 49. So our final answer is 49x to the 8th. Okay, let's look at the next one again. Simplify the inside if possible first. Ooh, I don't want to go that thick. All right, so 5 over 10, we can simplify to 1 over 2. We have 3 x's on top and 1 on bottom, so when you cancel, there's 2 left on top. Actually, this is x to the 10th. I didn't read that right. Okay, so we have 10 x's on bottom and 3 on top, so when you cancel, there's 7 left on the bottom, and you have 1 y on the top, and that doesn't cancel with anything. Now we take everything to the 5th power. 1 to the 5th is still 1. Y to the 5th power is y to the 5th. 2 to the 5th power is 32, I believe. I better double check. 32. And then x to the 7 times 5, which is 35. So our final answer is y to the 5th over 32x to the 35th. Okay, our next one, we just look at common bases. First we have 2 and 4. We can multiply those. That's 8. Then we have 1x here and 3 x's here, so that's x to the 4th. We're going to add those exponents. We have y to the 5th, y to the 7th. Add the exponents. You have 12 y's. So there's our answer. 10, it's everything to the 0 power, which is just 1. 24, let's see the inside. 24 divided by 6 is 4. You have x to the negative 2. I'm going to flip that to the top and add it to here. Oops. So we have 5 on top plus 2 more on top. That's x to the 7th. Y to the negative 3, we're going to flip to the bottom, and you'd have 3 y's on the bottom plus another y, so that's y to the 4th. Okay, let's look at the next one. Instead of having it to the negative 2 power, let's flip it, so it'd be 1 over 4x cubed y to the 2nd power. And then we'll distribute, so this is 4 squared, x to the 6th power, y to the 2nd power, and so that'd be 1 over 16 x to the 6th y squared. Okay, our next one, again it's negative, so let's make it positive but flip the inside. And then we'll distribute it to all of the exponents, so it'd be 4 squared over 3 squared x to the 10th, which is 16 over 9 x to the 10th. Our next one, negative 4 to the 3rd power does mean negative 4 times negative 4 times negative 4. Which would be negative, because a negative times a negative is a positive times a negative is a negative, and we'd had 64. We would have 64. In our last one, it's negative 7 squared, and notice we do exponents before we multiply by negative 1, so it'll be negative 49. Okay, so then exponents comes before multiplying by negative 1. All right, your assignment will be to name and practice these properties of exponents.